So today we're going to look at envelope. The following weeks we look at each of these. Okay, so let's refresh a little bit. This is, let's say it's a human. We understood how humans and buildings interact and how comfort is perceived, right, in our first week. So the one thing that is common between a human and a building, there's many things that are common. The important aspect that is common is there is constant exchange of something between the building and the environment, similar to the human and the environment, right? What are those things that are constantly exchanged? We're exchanging energy constantly. We're exchanging light constantly, smell, air, and moisture, right?
Sound.
Oh, did I miss sound? Yes, we are exchanging sound as well. Good catch. So just keep that in mind on the back of your mind. When it comes to building envelope, there are four terms to keep in mind. This will help us think about the building components, envelope components. I'm going to explain what these are. Connectors. Can anyone tell me what connectors are in terms of building an envelope?
Connect the windows and the
yeah,
it holds the elements together.
Correct. Okay, so that could be just an opening in the wall or a courtyard, right? Barriers would be your walls. A barrier could stop energy, light, smell, or any of these things, right? And filters. Window is a filter. It filters light, but it's a barrier of sound and other things. I'll tell you why it's important to think about it like that. And then switches. This is the most important thing when it comes to passive solar or passive heating and cooling strategies. Switches. Because let's take an operable window. When it is in the closed position, what is it?
Barrier.
It's a barrier.
Or filter.
And a filter.
Right.
But when it is open, what is it?
Connect.
Right. So that operable window is called a switch. It just like humans can switch shirt, building envelope needs switches. Okay? We'll see why. All right. So I'm going to go into the questions and the facts. We're going to look at climate consultant, and the analysis we'll look at Autodesk Vasari. Okay? So for the building side, I have 5 questions, and the reason is I just want us to ask these 5 questions on all the jobs. So this will, if based on the answer these 5 questions give you, that will be your outline for your 2030 story. Okay? So the first question is, this is probably at a 30,000 feet level question. What do you want your architecture to be? Do you want the architecture to be a performing arts, or do you want it to be a sculpture? Meaning, if it is a sculpture, you don't have a switch. It is static. Right? The sculpture doesn't change. It is a sculpture. It's fixed. But if it's a performing arts, it dances with the environment. I'm going a little philosophically, but it dances with the environment, right? So your building adapts to the environment by using its switches. Okay? So answering this question will help you narrate that story in the beginning really clearly, because that is a conscious decision. You're saying, nope, my owner doesn't want any switches on my building. He doesn't want to maintain an operable window. I can't design an operable window because I can't rely on my users. They won't close when it needs to be closed. So if you answer all those questions, this is out of the picture. You are designing a sculpture.
To a degree. I mean, if you go back a page to all those elements that are exchanged in a building, any element within a building is a switch that allows for those exchanges. And there's no way to do a building without those exchanges.
Well,
so, I mean, I don't know how we could ever be an or.
No.
It's got to be an and.
Yes, it'll be a combination, but there are extremes, right?
Yeah.
You could design a building that is completely performs as a performing arts. The simple answer is an awning.
Okay.
You could have an awning when it's needed, or you could take it down when you don't need it. So you and your project team and your owner are willing to design with those switches so that the building facade changes and the building envelope changes, operable louvers. because there are two types of
that
switches.
a higher tech version of it.
Right,
Okay.
because there are two types of switches. Thanks for bringing that up. One type of switch is the manual switch. The other one is the automatic switch, right? The manual switch is the difficult part because we have to train them and teach them. But the automatic switch is also difficult because it's costly.
It's a high first cost.
Right.
Okay.
So, passive technologies, if we want to use any kind of passive technology, solar, heating, or cooling,
Frank,
some level of, yes.
back to that analogy that you use, performing art or sculpture, I have heard another definition, which is a smart building versus dumb building.
Correct.
Smart building is a building that you walk in the room, the light comes on.
Yep.
And it responds to the environment and the climate and all of these things. But a dumb building is the building that is static.
Right. And again, the switch in that situation is actually in the lighting part, and you're doing an automatic switch here. So those are questions to ask. Well, when we look at the lighting side, we'll ask these same questions. What kind of switches do you want, owner?
Right
So
now,
that'll help us inform our design and write the story. So the important thing to understand is, from an envelope side, if we want passive heating and passive cooling strategies to solve the EUI problem, we need some kind of switches. That is a given. Because the climate changes constantly around you, around the building. So our building has to adapt to it from an envelope side. And it needs to have switches. Because if you just go by mechanical equipment, your building could be a sculpture and not a switch. Your mechanical equipment can take care of the changes.
Lots of switches.
A lot of switches.
It takes energy to do that sometimes.
Right. And it's not the best way to reduce EUI. Okay. Second question. Do you want a connector-dominated building or do you want a barrier-dominated building? That depends on the climate to some extent, right? If it is a milder climate, when the outside temperature is relatively closer to the inside temperature, then you want an open connector, I'm just using a little TP here, a connector type building in concept. So it's very important to ask these two questions. And I'll tell you why. Before I get into that, for a harsh climate, what's the best response to a harsh climate?
Be a barrier.
You want a barrier building, right? The reason why it is important is the average EUI of the buildings out there could be whatever, and they could be of masonry buildings, they could be of stucco buildings. So there is no benchmark for you, right? So when you're starting to design your building, what is your benchmark? Your benchmark is the most climate responsive design that makes sense. So if you're designing a building in a milder climate, the closest, your baseline building should have a lot of connectors, because that's typically what you would do, right? On the same hand, for Phoenix type climate, your baseline should be a dumb box, because the energy consumption of your baseline is your starting point. And then from there, you want more windows, you understand what type of penalty you're getting. You want a thin, narrow building, you understand what type of penalty you're getting. Then you try to solve, okay, now I took 6 EUI as a penalty. How do I solve that? Do I put windows? Do I put sunshades? So that's a logical way to think this. You need to have a baseline. Otherwise, what are you comparing against? Make sense?
Agreed.
Okay. Third question. The most important thing that shapes our building envelope is this guy, daylighting. So it is very important to ask. It's not a simple question to ask your owner, okay, do you want daylighting or not? Don't ever ask that question. Ask a more detailed question. Do you want even distribution in every single space? Do you want only in the core educational spaces? Do you want it in the transition space? Ask more detailed questions based on your program. And ask where and to what extent do you want daylighting? Because there are several metrics based. A simple example is, if I want 30 foot candles on this table, then I have to have a certain amount of opening. But if that parameter changes, I only want 20-foot candles on the table, it changes the building design totally, right? So it is important to ask where and what. And then this is very, very important. We seldom ask this question. Do they want us to, well, of course they want us to solve glare. But to what extent? That's a question. And we'll spend a lot of time next week in daylighting and how it relates to lighting. Yes?
I think we also have to ask how much visibility they want.
Yes, that's a good one. That's a good one. We would need to know that, because daylighting is also, visual connection is also important.
Right.
And then the last one, if they're really interested in EUI, energy savings through daylighting, if you don't do this piece, there is no use in using daylighting. No use in doing any kind of daylighting strategies. If there is no automations or controls to stop your light from turning on, because then you are relying completely on your users to do that. So again, that's a switch on the lighting side.
But if they don't want automated controls, to what extent still has to incorporate how much you don't want to use your lights?
That's a very good question, because if they don't want to spend their effort and time on automation and controls, then that changes your daylighting strategy. Because why?
You said why?
Yeah. Because
how you do your windows at that point.
Because the problem is, if you don't, okay, the ideal situation is when the sun provides enough foot candles on your table, you want to turn this on. The not so ideal situation is when the sun is still providing 30-foot candles and this is still on, right? Best case, worst case. So if you don't have an automatic control, you still have to worry about the radiation due to the 30-foot candles that you're doing, right? So if you don't want automation and controls, then your strategy should be different. You can't let direct sun come into your building because you don't want radiation. Why? It will contribute to your cooling load. You want to diffuse it and change your strategy on the windows, on the sides, to bring the same 30-foot candles. So it impacts our design. So it's very important to ask these questions right in the beginning. Let's take a look at the pie chart for a school. We looked at equipment and lights are major, and then the rest are heating and cooling. In Phoenix, heating is really low, and cooling is a lot higher. So let's break this down into the different parts that make up the heating and cooling. Envelope-wise, we have the roof, we have the walls, and window, we have two. The conductance of the window and also the solar radiation of the window. So until here, this is not by any means proportionate. I'm just drawing. So until here is what the building envelope contributes. And then the rest is occupants and the ventilation for the occupants. The last one is infiltration. We will get into this in a couple of weeks. So what we're going to majorly deal with is those four guys. We'll talk about those four guys today.
Roof, wall, windows.
I'm sorry?
Roof, walls, and windows.
Roofs, walls, and windows. Yes. All right. These are. This could be a little bit more complicated, but I think it's important to ask these questions. 4 and 5. As an owner, you know that in Phoenix there is very limited heating needed, right? So do you want to ask your owner, do we want us to design so that we take advantage of free heating? That changes your design. Because there's a little bit of window in a year that needs heating. So it is important to ask that question, do I want to take the sun's heating for those winter months? Then that changes your design. So ask that question. It could be a simple no, but at least you can write your story now. And as far as free cooling goes, it goes back to some of the passive cooling strategies. It is important to ask the free cooling question. This is something your client wants to pursue.
Why would any why would any client say no to something free like that, though?
That's our responsibility to explain why. Because how would you do free heating? You'll have to have solar sun, south sun heat your building mass.
Trompe walls.
Trom walls, those are things that are new. To some of our clients, it has maintenance items, and through mechanical design, we can't prove them that they work. We have to rely on hand calcs and other things. So is the client willing to take that bet with us? Because how would you design a Trom wall in using train trace? You can't. So our guys will still put the mechanical equipment to meet the heating load. So if our client says, all right, let's take this risk, then you kill the boiler in Phoenix and go with this design. The other issue is, we can hand calculate how much thermal mass we need based on the aperture to heat the building so that it releases that heat during the heating season. We can do that. But the clients have to be comfortable with that, because any passive cooling strategy or heating strategy will have this climate comfort slightly stretched. Just think about your house. If you let the passive strategies take place, it's always not 75 degrees. It's going to go up and down. What happens if there is a cloudy day? You're screwed, right? 75 will go to 70 degrees. So the client has to be okay with that. It is our imperative to bring that forward to the client and at least ask these questions.
With some suggestions ready to be made.
Yes.
Because I'm not sure they'll all be able to answer that question without asking us how we're going to do it.
Right, and we're going to look at how in the due course of time. And so likewise with the cooling, and I talked about this earlier, with the simplest cooling strategy here is to have, we'll look at this in a minute, night flushing or direct evaporative cooling. How many of our clients will accept direct evaporative cooling?
Only in very limited spaces.
So it's important to ask that question, because we can show them that will be one of the heaviest strategies to reduce energy consumption. Are they willing to take into account maintenance and the other things?
That's what I was going to say. The closer we get to 2030 constraints, 70%, 80%, some of these become more mandated than just options that you can pose as questions.
Right, which is what happened during the oil embargo era. Everybody started designing like these things, right? We may be there. So it is important for us to design this. I mean, there's two components to this. One, energy consumption, and then two, mechanical engineering design. The mechanical engineering design will not change. At least.
How do we deal with free cooling in the terms of operable windows?
How do we deal with it?
Yeah, because the big argument for operable windows is to take advantage of natural ventilation, but then it needs to be HVAC
Right.
has to be
Right. So some of the smart buildings, as you call, take care of that by automating that. So they, if the climate is really nice outside,
right.
These windows, there are technologies to show a green light and a red light right by the window, so that intimates the users to open that and use that. But at the same time, we have to also think about that it's going to bring dust. So how do you have to put more money on your filters.
Or your maintenance crew just vacuuming and cleaning the books and shelves. And
Right. So there are a lot of compromises here. So which way do we go is very important. Maybe we design a sculpture. That's fine.
Right.
But it's good to ask these questions, and at least so that we can logically say, this is our story, and this is why we're doing this design. Does that make sense? All right. So here's the process. We ask the questions during our visioning exercise. This is the first thing we do, right? For building envelope, building lighting, HVAC systems, and renewable, we ask those questions during the visioning session. And then we do the next step is to do fact finding. So we use climate consultant, utility bills from the owner, and just client interviews on how they are operating the building. Because I'll show you, it's very important to know how they are operating the building right from the beginning, at least an idea of how they are willing to operate this building. because that will change your passive or sculpture design. Then the next thing to do is to find out the best shape, form, and orientation for your building design based on a baseline that suits your climate. And there are multiple tools that can do this. I'm going to talk about Autodesk Vasari today. And then once you do this, then we can explore some passive technologies. Unfortunately, many tools that are out there today cannot effectively do these passive technologies. And for instance, it's very difficult to use Train Trace or any of the programs we have to do natural ventilation, to figure out natural ventilation. So you have to rely on hand calcs for now. Some tools do one part of the puzzle better than the other tools, but not all the tools do all of them. So it's some tools, they don't even take into account the thermal mass effect. So it's very difficult to analyze that today without having to use hand calcs. And the hand calcs are all there on its books. And then lastly, but we can still explore assemblies and daylighting through the tools that we have today. Everybody agreeing that? Questions? I'm done with my show and tell. I'm going to go to the climate analysis, push some buttons.
All right.